All right, so today I'm going to be presenting on tips and tricks for Next.js and Sitecore Headless. My hope is that you can walk away with some cool things that you can use on your Next.js projects, your Headless SXA projects right away after this presentation. So I'm Corey Smith. I'm an independent consultant in Atlanta, Georgia. I'm an 8-time Sitecore MVP of Technology with over 9 years of Sitecore experience. I'm a happy dad to an 18-month-old, and I'm also a lawn care and smooth jazz enthusiast. So if you like either of those things, please reach out to me on the Sitecore Slack at Sitecore, and you can also visit my website blog at coreysmith.co. Every Friday at 12:15 p.m. Eastern Time, I co-host with my good friend and fellow Sitecore MVP, Jim Patillo, a virtual Sitecore meeting called Sitecore Lunch. Sitecore Lunch is a virtual meetup that we have on Zoom, and it's just an opportunity for members of the community to unwind on Fridays and chat about Sitecore. Oftentimes, we chat about more topics other than Sitecore itself. The details to join are here on the screen. So every Friday at 12:15 p.m. Eastern Time, without fail, 52 weeks a year, in the Sitecore Slack general channel, I'll post the details to join. If you're not on the Sitecore Slack, please join us. The URL to join the Sitecore Slack is there on the screen, sitecore.chat. Hope to see you this Friday. Our first tip today is looking at the debug logging functionality in Sitecore's Next.js SDK. So Sitecore's Next.js SDK ships with pretty extensive debug logging functionality that's provided by an NPM package called debug. When you enable this, it's going to output tons of handy debug information to your console logs and even to the browser for things like layout service requests and dictionary service requests like you see here. So this is really handy for debugging issues with your site. This functionality is hiding in plain sight in every Sitecore Next.js project. So if you open up the .env file in your Next.js application, you'll see this block of comments that I've shown here. And all you have to do to turn on the debug logging is just uncomment this line. So when you uncomment this line, you're turning on all the debug logs that Sitecore has made available. But you can be more selective. So if you uncomment this line instead, the only thing that you'll see are debug logs for layout service requests. Or if you uncomment this line, what this will actually do is this will show all the logs except for the layout service requests. So this functionality is pretty cool. You can get really selective and creative to see exactly what you need to diagnose your issues. And these are all in the default .env file for you to play around with and learn from. Something that's not in the .env file by default is this setting, debug multiline. So I highly recommend that if you're going to use this functionality that you take note of this, because you're going to want to set this to true. Basically what this setting does when you put it in your environment variables or your .env file is it's going to make your debug logs a lot more readable. So when you uncomment those lines that I showed before and turn on debug logging, this is what the debug logs look like in the console by default. But when you turn on debug multiline, they become a lot more readable. It's a lot easier to parse. And yeah, so I definitely prefer this view and encourage you to use that setting anytime you use debug logging. Sitecore ships with a ton of debug filters. This is an exhaustive list of all the debug filters that are available. If you want to turn on all debuggers, you just set debug equals Sitecore JSS star. If you want to turn on just the data fetchers, you would set Sitecore JSS HTTP. If you want to see layout service, dictionary service, there are filters for those. If you're trying to diagnose issues with the experience editor or pages, you can filter to the editing host logs. If you're using Headless SXA, they've got filters for sitemap service, site info service, robot service, redirect service. And if you're using CDP or personalized, they even have filters for those services as well. So we looked at debug logs in the server console, but you can actually turn on debug logging in the browser, and it's a little bit different. The environment variables that you set on the server in the .env file or in your server environment variables won't affect the browser. So to turn on debug logging in the browser, what you'll do is you'll open up your browser console and set the debug property on local storage to the filter that you want to expose. And when you do this, then in your browser console, you'll start seeing any kind of debug logs come through. Now, I will warn that on a fresh Next.js application, you're not going to see any activity at all probably come up in the browser console if you turn this on, because by default, almost all of the stuff that Sitecore is doing in a standard Next.js application happens during server-side rendering. But don't be alarmed. We'll come back to this in a future tip, and I'll show you where this can be really helpful. So to recap, you can enable debug logging for your server in the .env file. Remember to set debug multiline equals true for readability. If you want to turn on debug logging in the browser instead of the .env file, you'll do that by setting the debug property on local storage. And in fact, you can create your own namespaces in your applications and your components by using the debug function. If you're interested in doing that, check out the debug documentation on the npm.js website. That'll show you how you can create your own namespaces for debug. And then Sitecore's got really good documentation on the debug logging that they make available. All right, for tip number 2, we're going to look at the data fetchers provided by the JSS libraries. So something that we'll commonly do in our applications, of course, is integrations with external systems. We need to make API calls. Usually you'll do that using a library like Fetch or Axios, but the Sitecore JSS library exports 3 data fetchers that you can use in your application that wrap these things. So there's the native data fetcher, which wraps Fetch. There's the Axios data fetcher, which is a wrapper around Axios. And then there's the GraphQL request client. The native data fetcher, I recommend you're going to use most of the time. The Axios data fetcher, I just bring it up here just to call it out, but you're probably not going to use it. The native data fetcher, again, that wraps Fetch. And Vercel, the team that maintains Next.js, they actually ship their own implementation of Fetch with Next.js. So if you use the native data fetcher, anytime that you upgrade your Next.js framework, you're going to get improvements that Vercel make to Fetch for free. So Vercel has implemented things like request deduplication and caching in Fetch. And if you use the native data fetcher, you'll get those features for free. Axios data fetcher won't come with that kind of thing. So probably don't worry about that. The GraphQL request client, that is really more focused on making requests to the Sitecore GraphQL APIs. And it's really cool because it's got retry logic built in and it handles rate limiting of the Sitecore APIs. So anytime you're making those kind of calls, you'll use the GraphQL request client. The advantage to using all 3 of these is that they're configured to use debug logging out of the box. So if you use them to make an API call, anytime you turn on debug logging for the HTTP filter, you'll start seeing logging from these methods. They're pretty easy to use. So if you wanted to use the native data fetcher, for example, you just import it like this, new it up, and then call the fetch method on that function or on that class. It's a lot like using fetch directly. Again, if you turn on debug logging for all the namespaces or just for the HTTP filter and turn on debug multiline equals true, anytime that you use those data fetchers, they'll start showing up in the console like this. So you'll be able to see the requests and the responses that are coming back for those data fetchers. If you use these data fetchers in client-side interactions, for example, in a use effect, when you turn on debug logging in the browser by setting that debug property on local storage, then you'll start seeing the logs come up in the browser like this. So again, use the native data fetcher instead of fetch. The Axios data fetcher is there instead of Axios, but you probably don't need it. if you're calling Sitecore GraphQL APIs, always use the GraphQL request client. And the nice thing about all three of these is that they integrate with debug logging for diagnostics. For this tip, we're going to look at component level data fetching in the Sitecore Next.js SDK. So let's start by looking at a typical data fetching scenario. This is just a typical React component, and it's using the useState useEffect pattern to make an API call. This is the standard data fetching pattern you'll use in React components. So you use these two hooks. The first thing, anytime you want to make an API call in a React component, you'll use the useState hook to declare some state, and then you'll use the useEffect hook, and inside of that, make your API call. When your API call finishes, you'll set the state to whatever the result is from your API, and this will trigger a re-render of your component so that you can re-render the component with the data from the API. While your component is rendering, you might show a loader, like some loading text, and then once it's finished loading, you'll actually show the data from the API. So this is a standard pattern. The problem with this pattern is the useEffect hook, because the useEffect hook only executes on the client and in the browser. It doesn't execute during server-side rendering. So with that loading pattern that I showed before, on a page that's got a lot of these components making API calls using this pattern, you're going to get loaders like this, right? There's going to be a delay and a flash of content. This isn't the best user experience, and it can have negative impacts on SEO for your site. But the cool thing is Next.js actually has a solution for this at the page level. And that comes in the form of two functions called getStaticProps and getServerSideProps. These are server-side data fetching methods that you can use to do data fetching during server rendering. So what I showed before was a method to do client-side rendering. Next.js gives these methods to you to make these kind of API calls on the server. If your application is using static site generation, SSG, you use getStaticProps. If you're doing server-side rendering, SSR, you would use getServerSideProps. So let's look at an example. Again, right now we're just talking about a standard Next.js application. Sitecore is completely out of the picture. And in a standard Next.js application, you export these functions at the page level. So here I'm showing a page that we've got defined in our app. And to use these functions, all you do is alongside your page, export getStaticProps or getServerSideProps. Then inside that exported function, you can do something like make an API call, as I've shown here, or you can do some computationally intensive tasks that you don't want executing on the browser. The next thing you do is after your data is retrieved or calculated, you can return that from the function. And Next.js, what it'll do is when it's rendering the page server side, it'll take that data and pass it to the page as a prop. And from that point, it's just a standard prop. You can pass it down to any component that you like on the page. So this is a really nice feature. We can avoid content flashes and improve SEO by taking advantage of this. But there's a big problem. Since these methods have to be declared at the page level, if you've got a bunch of components on the page, you must do data fetching for all the components on your page here. So in a vanilla Next.js application where your pages are static and you know all the components that are going to be rendered ahead of time, this might be okay. Like in this example here, I'm showing a page that's got 4 components, and we know ahead of time that these 4 components are always going to get rendered on the page. So it's okay to do data fetching for all 4 of those components every time. But in a Sitecore application, we don't know ahead of time what components are going to get rendered on the page. For example, like in most Sitecore applications, at the page level, all you're going to have is a placeholder. And inside of that placeholder, your content authors are at runtime deciding which components are going to render on the page. So it would be very wasteful to say if you have a component library of 50 components, to be requesting data for all 50 of those components on every page when maybe only 4 or 5 of them are going to get used. So the cool thing is Sitecore has actually come up with a really elegant solution for this to solve this issue. And that comes in the form of component level data fetching, where we can declare these functions not only at the page level, but we can also declare them at the component level. So let's take a look at that now. So here's our example from before, where we're using the combo of useState and useEffect to make an API call on the client. We can refactor this now using Sitecore's component level data fetching feature, and this is what that would look like. So now my component, alongside my component definition, I can just export get server side props or get static props, and inside of that, make my API call, and then once my API call finishes, return the data, and Sitecore is automatically going to take that data that I return from the function, pass it as a prop to my component, and I can use it. So you can see here that I don't have to have any kind of loader or anything like that. This data is going to be fetched and rendered completely server-side. So going back to our screenshot from before, yeah, there's no loader or anything to show because that's all going to get generated during server-side rendering and be part of the initial HTML that gets sent up to the browser. So that's really nice. There's one thing to keep in mind. So if you are using a version of the JSS libraries, the NPM packages that are before 21.6.4, heed the warnings that I'm about to tell you. There's a major bug in the versions of JSS before 21.6.4 that can get you in trouble when using these methods. So the page level get static props and get server side props are excluded from the client bundle, meaning that they don't get sent to the browser at all. And that makes sense, right? These functions are only executed during server side rendering. There's no sense in sending them to the browser. Vercel actually says in their documentation for Next.js that because of this fact, you can put things like connection strings, API secrets, whatever in these functions, because these functions are only going to stay on the server and never get sent up to the browser. However, component level get static props and get server side props are not excluded from the client bundle on versions of JSS before 21.6.4. This was a bug in the JSS SDK. So keep in mind, if you want to use those functions on an older version of JSS before 21.6.4, you cannot, under any circumstances, put sensitive data in those functions. Because if you do, if you put a connection string, a password, an API secret, whatever, someone who navigates to your site will actually be able to look inside the JavaScript bundles that are sent up to the browser and in plain text see that data. So just keep this in mind. With that being said, I still think there's a lot of value in these functions, even on the older versions of JSS, because yeah, it's really nice being able to keep that server-side data fetching code so close to the components that are actually going to use it. So to recap, you can now in a Sitecore Next.js application, you can use get static props and get server-side props not only at the page level, but at the component level. If possible, upgrade your libraries to JSS 21.6.4 or higher as soon as possible. And if you can't upgrade to those versions, then just remember, don't ever put sensitive data in those component level functions. The page level functions are still safe, the component level functions are not. So some further reading, the first URL that will take you to the release for JSS 21.6.4. And you can actually, if you're curious to see how they fixed that issue, you can see that there. The second link is a link to the issue that I actually opened up on GitHub about this issue when I found it. So yeah, that's kind of a fun read to go through. Sitecore's got really good documentation on their component level data fetching features. And then Vercel's got really good documentation on the page level data fetching features that I mentioned before. So check all that out. Okay, so for the last tip, we spent a lot of time talking about server-side data fetching, and now we're going to switch back up to the browser to talk about a library that will help you do client-side data fetching and supercharge that. Because there are still cases where you're going to want to make API calls on the client only for some interactivity or whatever. So let's take a look at a better way to do that. So going back to our example from before, where we're calling the cat fact API using the standard React pattern of use state and use effect. Again, it's kind of kludgy. Anytime you want to make an API call on the client, you've got to use state, and then you have to use the use effect hook to actually make your API call. Once the API call returns data, set state to trigger a re-render with your API data. You might show a loader while your state is null, which again is kind of kludgy. And then once your state is not null anymore, then you could show the data from the API, for example. So this works, but there's a better, cleaner way, and that comes in the form of a library called SWR. This is a library that's built by Vercel, and this is basically just a really nice hook for data fetching. SWR stands for stale while revalidate. So let's take a look at that. So here's our component from before, and I have rewritten it to use SWR's hook instead of using use state and use effect. It's quite nice. Now all you have to do is use one hook. You don't have to use two. So you just use this use SWR hook. The first thing that you do is you pass a query key to it. The query key is usually going to be an API URL. Like in this case, it's just the URL to the cat fact API. And the second thing that you have to pass to it is a generic fetcher function. So this function just tells SWR how you want it to retrieve the data. In this case, I'm using fetch. Then the SWR hook will return some data to you. It'll return a parameter called isLoading, and this is just a Boolean that tells you whether or not the API is loading data. It'll return an error object if there's an error that comes back from your API. And lastly, it'll return a data object, which will actually contain the data that comes back from your API. And then the cool thing is you can just use that isLoading Boolean to determine whether or not to show your loader. You're not doing something kludgy like checking if state is null or whatever. So this is, I think, a lot easier code to grok. This is more maintainable, but more maintainable code isn't the only thing that you get from SWR. It comes with a whole bunch of features. SWR comes with auto refetching. It comes with request deduplication. It's really good at handling dependent query scenarios. So if you've got multiple queries that depend on each other and they have to execute in a chain, it can set that up for you really well. It can do prefetching. It can do caching. It handles pagination, infinite scroll, and it's got full TypeScript support out of the box. So next, let's take a look at two of these features in action. So I've got a page here, and this has that cat fact component on it added to the page 4 times, and I'm using the use SWR hook. So one thing that you get for free with SWR, you don't have to do any configuration. This is something you just get for free when you start using that hook, is auto refetching. So what I'm doing here is I'm just clicking in and out of the browser. And every time I click back into the browser and the browser regains focus on that page, SWR is going to go and automatically do a refetch on all of my API calls. So this is really nice if people are navigating to your website and Alt-Tab or whatever, go away from the browser for a while. When they click back onto your website, SWR will just go and get all the latest data for them automatically. So that's a pretty cool thing you get for free. Another thing that's happening here is a little bit more subtle. So I've got this component added to my page 4 times. If I had used that use state and use effect combo, what you would actually see here on the page is 4 different cat facts, right? Because this cat fact API, every time you call it, just returns a random fact about cats. But what you're actually seeing here is you're seeing 1 fact, and that's because SWR is doing request deduplication for you automatically. What SWR is doing is it sees that you've got the same component on the page making the same request 4 times. So instead of making that request 4 times, it'll actually deduplicate the requests, make the request once, and then share the response across all the components. So you get a nice performance boost there for free. I showed previously with SWR that you supply it a generic fetcher function. you don't just have to use fetch here. So if you wanted, you could use the native data fetcher that I talked about earlier, or use the GraphQL request client, and that'll work just as well too. And when you do this, you get the benefit that all of your SWR hook calls, they will work with debug logging. So you will get to see those show up in the browser like this when you set that debug property on local storage. SWR's got a really nice browser extension. If you install this in your browser on a site that's using SWR, then you can do things like inspect the SWR cache. You can see the history of all the calls that are made, and then even inspect the network calls. So this is a really nice debug tool. So to recap, SWR simplifies and supercharges data fetching code. But it's not the only game in town. There's a really great alternative to SWR called React Query. I've used SWR and React Query with great success on projects. It really comes down to what works best for your team. I highly recommend that if you've never checked out these libraries before, to check out both before you settle on one in your project. Further reading, Vercel's documentation on SWR is the first link. If you're interested in the dev tools, that's the second link. And then check out the React Query website, the third link. React Query's got a very similar feature set to SWR. It's a nice tool. All right, so for this tip, we're going to look at mocking data for pages and the experience editor. And this tip is going to combine tips from the previous two sections. And this is the last time that we're going to talk about data fetching today. So when we're building a site for Sitecore, we're really tasked with building two applications. You're going to build the application that end users see, your live site, but we're also building an application for XM Cloud pages and the experience editor for our content authors to build pages. Something that I stress you should keep in mind is that pages and experience editor are for designing layouts. They are not for testing and showcasing APIs. So in pages in the experience editor, rather than making any kind of API call, it's better to just serve up mock data for your components that give your content authors an idea, a representative idea of what the component is going to look like. And the reason for this is that React re-renders or any kind of client-side rendering can break the experience editor. The experience editor is very sensitive to client-side rendering. Pages is a bit more resilient, but still using React re-renders or client-side rendering that are caused by API calls, for example, can break those experiences for your content authors. So let's take a look back at our cat fact example. I've changed this a little bit from what we've looked at before, but the idea is the same. So we're using SWR to make an API call, and while the API call is loading, we show a loader. But then once the API call is finished, we show the data from our API, which is fine. But what's going to get us into trouble is the fact that we're rendering an image field helper to show an image field from Sitecore, and we're rendering a placeholder after the API call is loaded. We're doing conditional rendering of the image field helper and the placeholder. And if you do this, you will absolutely break the experience editor. There's no question. Pages can struggle with it as well. This is an anti-pattern. So you can't ever do conditional rendering of the Sitecore field helpers or placeholders in the experience editor. And the kind of things that you'll see when you do this, inline editing won't work. When you first add your components to a page in the experience editor, they won't render. So you might have to save the page in the experience editor and refresh the experience editor to get the component to render properly. And the other thing is that placeholders won't work. So when you try to use placeholders that are set up like this, you'll get an error that says could not find the rendering in the HTML loaded from the server. So now I want us to take a look at a way that we can use SWR and the component level data fetching feature to serve up mock data in the experience editor or pages and avoid all these problems. So let's go back to our component. It's, again, calling the cat fact API, and it's showing a loader, right, while the data is loading. Otherwise, it's just showing the data from the API. And we're going to refactor this so that it won't make any API calls in the experience editor ever again, and it'll just return mock data from the CatFact API, and it's going to look like this. But this looks like a lot more code, but it's not too bad. We'll break it down. The first thing that we're doing is we're exporting get server-side props or get static props alongside our component. Inside of that function, the first thing that we do is we check if we're in Pages or the Experience Editor. And if we're not in Pages or the Experience Editor, don't do anything, because we don't want to interrupt that flow. Like, the live site works fine, conditional rendering works fine on the live site. But if we are in Pages or the Experience Editor, then we'll return some mock data. So we've got our mock data, we're returning that. Sitecore is going to pass that as a prop to our component in Pages or the Experience Editor. And the next thing that we do is we take that mock data and we pass it to the fallback data property of SWR. This fallback data property, what this tells SWR is, hey, while the API call is loading, serve up this fallback data. And then once the API call finishes, return the real data. So this gives us a mechanism to inject mock data into SWR. But we've still got a problem, right? Because we don't want that API call to be made still. Well, SWR has got a really nice way to handle this, and that's handled at the page level. So we go to our page component here, our Sitecore page, and we declare an SWR config element like this. And so this is like at the root of our application, we're declaring SWR config. And what we do is we set revalidate on focus and revalidate on mount to false when we're in the Experience Editor. And basically what this tells SWR is when we're in the Experience Editor or Pages, don't make API calls. If we provide you fallback data, return that, but don't ever make the API calls. And that's really all there is to it. I think that this is a really clean way to provide mock data to your components in Experience Editor and Pages and kind of avoid those issues that I was talking about before. So to recap, in Pages or the Experience Editor, don't call APIs. Don't do client-side rendering of any kind of JSS field helpers or placeholders, because if you do, it's going to break the Experience Editor and Pages as well. Instead, you can return API mock data for editing in the components get server-side props and get static props. One other benefit that you get for putting your mock data in get server-side props and get static props, if you're using JSS 21.6.4 or later, is that your mock data won't ever get sent up to the browser. It's going to stay entirely on the server, so you don't have to worry about like, oh, I need 5 megabytes of mock data. Doesn't matter. Won't get sent up to the browser. It stays on the server entirely, so that's cool. Then you take your mock data from those methods, pass that to SWR's fallback data, and then turn off the API calls in Pages in the Experience Editor by disabling revalidate on mount and revalidate on focus. And there you go. I think that's a pretty clean pattern for this. Okay, that was a lot of stuff. So let's have a really easy tip. And this easy tip is, again, looking at Pages in the Experience Editor in a way to avoid some other issues you might run into there. So something that I see pretty frequently in React components is in React components, the component will get wrapped with a React fragment like I've shown here. Because React components, they have to have one root element. And yeah, sometimes you don't want a div or a span. But the problem is that if you do this, you can cause some issues in the Experience Editor. The things that will get caused in the Experience Editor from you using a React fragment as the root element is that styles will get broken in Experience Editor and Pages. Again, inline field editing won't work properly when you insert your component to the page, and placeholders won't work properly. The fix is pretty easy. All you have to do is just make sure that your components always have a real root element, such as a div or a span. And if you do that, you won't have these kind of issues with your components. It might be a good idea to develop a community module like an ESLint or a Prettier plugin to detect this issue. I'm sure this is something that could probably be detected pretty easily with those. And I'd also like to call out that this isn't something that's just specific to Next.js. This problem actually goes all the way back to the days of XSLT, web forms, and MVC. If you don't have like a single real root element in those technologies either, they'll have similar problems. So, yep, just keep that in mind. Tip number 7, this is an easy one as well, disable Next.js telemetry. So Vercel actually is collecting a lot of telemetry from your Next.js server that's running in production. They use this telemetry to figure out what features to develop, help diagnose bugs and things. If you or your clients are privacy focused and don't like that, you can turn the telemetry off very easily. Just go into your env file or in your environment variables, set next telemetry disabled equals 1, and yep, you won't have telemetry collected and it won't get sent back to Vercel anymore. So you just check that into Git and you're done. Sitecore's got some documentation on this. You can check that out at the first URL. And then Vercel's got some documentation on this as well. That's not the only way to turn off the telemetry, but I think it's the easiest. For this tip, we're going to look at a feature in the Sitecore Next.js SDK that will help you with upgrades, and it's another maintainability tip for your code, and this is Next.js config plugins. So at the root of all of your Next.js applications, there's going to be a next config.js file where you can configure all of the next configuration options that you want to set. A new Sitecore Next.js application is going to have a bunch of things configured here. Some of the things that you can set up for Next.js are environment variables. You can set default headers, changing image behavior. You can configure redirects and rewrites for the Next.js server or configure Webpack settings. And these are all great things to change in your application. But if you make changes to these in the next config.js file, it can make upgrades of your project a little bit more difficult when it comes time to incorporate any changes that Sitecore has made in newer versions of the Next.js SDK. So the Sitecore team's actually given us a cleaner way to make changes to the next config.js without editing it directly. And that comes in the form of something called config plugins. So in every Next.js application from Sitecore, there's a folder in the application at source lib next config plugins. And a new Next.js application from Sitecore is going to have a bunch of plugins in here for you to reference, but the plugins are always going to take this shape. They're always going to look just like this. This is the general template. So now instead of modifying the Next.js config directly, you can create a plugin inside of this folder and just tweak only the settings that you need inside of your file. And at build time, these changes will get combined into the next config.js. So if you're familiar with Sitecore config patching or web config transforms, this is very similar to that. So let's look at a simple example. Say, for example, that you wanted to turn off the Next.js powered by header. Instead of going and doing that directly in the next config, you can create a config plugin like this. Just create powered by header.js in that plugins folder. And there you just set powered by header to false. And now when you build your application, powered by header false is going to get magically combined into the next config.js, and that's handled for you. I will say that this example is pretty contrived, but if you have a feature that requires a lot of config setting changes, like imagine that you have a feature that needs redirects and it needs rewrites, and that feature also needs Webpack config changes. Going and doing those in the next config and having them kind of strewn about all in the next config is messy, but the config plugins basically let you have a myfeature.js with all those rewrites, all those redirects, all those Webpack configs packaged quite nicely in one file. So this makes your code a lot more maintainable from that perspective as well. The only caveat is that hot module reloading will not pick up any kind of config plugins that you create or change. So anytime you create or change a plugin, make sure that you run JSS start, next build, or restart your rendering host container. So to recap, Never edit Next.config.js directly anymore. Instead, create config plugins in the plugins folder that I've got shown there. And just remember that anytime you create or modify a config plugin that you need to rebuild your application. Okay, tip number 9, we're going to look at Next.js Bundle Analyzer. This will help you get a better understanding of your website payloads. To get started with this, you just run npm install next bundle analyzer and install this package in your application. And then the next thing you're going to do is create a config plugin. So instead of modifying the next config.js directly, create this config plugin that I've shown here. And yeah, you can just take this code exactly, take a screenshot of this. But the two important things is you're going to set enabled when the analyze environment variable is set to true. And you're also going to set open analyzer to false. Open analyzer, if you set that to true, that's a really annoying setting because every time you save or rebuild your application, Next Bundle Analyzer is going to open up a new tab in your browser, and it takes like 30 seconds for you to have 1,000 tabs in your browser. So just go ahead and turn that off straight out of the gate. So once you've got that in place, go into your environment variables, your .env file, set analyze to true like this to turn it on, and then rebuild your application. And when you do, Next Bundle Analyzer is going to create 2 HTML files at these locations in your application. It's going to create a client.html for your browser bundle, and it's going to create a node.js.html for your server-side bundle. When you open up the client.html page, it's going to look like this, and it's going to show you all of the bundles that are going to get sent up to the browser in nice chunks like this. So you can see that there's a main.js. This would get sent up to the browser. For the 404 page, this 404.js would get sent up. For your catch-all page route, this is what would get sent up. The app.js looks like this. If you look a little bit closer, you can see that node modules on a brand new Next.js application is actually contributing to the majority of the bundle size for your pages. You can see that the components, they're all right here. They don't contribute that much in a new application. But it's kind of hard to see that stuff, so there's a sidebar that you can open. And when you click on the sidebar, it'll actually allow you to drill into one of those bundles. So if we look at like the catch-all page route, for example, again, you can see here that Node Modules is contributing the most space to this bundle. If we drill down a little bit more, you can see that the Sitecore JSS libraries are contributing a pretty good amount as well. And then, of course, here are all the components that are actually going to get used. Another cool thing is you can actually mouse over any of these blocks, and it'll tell you exactly how many kilobytes that block is contributing to the bundle, or megabytes if you've got some huge code. The Node.js HTML is going to look a little bit different because it's going to have server-side code in it, right? So if you look here, you'll notice that all of these bundles have document.js in them. We didn't see that in the client-side bundles, and the reason for that is that document.js is code that only executes on the server side. So that's not getting included in the client bundles. So yeah, this is a really good way for you to kind of keep an eye and say like, hey, why is this code that's only executing on the server side showing up in my client bundle? That shouldn't be there. So yeah, to recap, you can use Next.js Bundle Analyzer to diagnose bundle sizes. Of course, you can use it to find code that doesn't belong in the client. That's probably the most useful reason to use it, and then enable it with the config plugin. And documentation for that module can be found here at this URL. Okay, our final tip today is about patch package. This is probably my favorite tip. And patch package is a utility that allows you to patch node modules. So if you've ever run into a situation where you're like, hey, I need to make a change to this file in node modules, but I don't know how to share it with my team or get this change to production, patch package is what you are looking for. You get started by running npm install patch package like this. And then in your package.json, you are going to add a post install script that will call patch package like this. And basically what this says is anytime npm install is run on your application or in your repo, after npm install finishes, patch package will run and it will take your patches and apply them to the node modules folder. But once you've got those things in place, you can go and start hacking away in your node modules folder. Here, I'm just showing the is-even module. So this is probably in every single node modules folder on the planet. And you can just open up node modules is-even index.js and make a change to it. So if you wanted to, you could make it so that is-even always returns true on Mondays. Say you want to share this with your team. Well, you just save this change in your node modules folder, and then you switch back over to the console and you run npx patch package is even. So you give patch package the name of the module that you modified. And once you run this command, patch package is going to go off and it's going to get a clean version of the module that you modified. And it's going to diff it with the module in your node modules folder. And it'll take that diff and it'll create a patch and put that patch in your repo. And that patch, you just check it into Git, you share it with your team, and now anytime someone runs npm install in your repo, that change you made to node modules will get applied to their node modules folder as well. Another thing that's pretty important is it's also going to give you a command after you create a patch to open an issue on the GitHub for that repo or for that module. I highly recommend that you do this. If you ever need to go into node modules and make a change to a package to fix a bug, to export something or whatever, you really need to let the package maintainers know. So get in the habit of doing that if you use this tool. Like I said, the patches, they'll get put into your repo. So they'll get put into the patches folder in your repo. A patch looks like this. It just looks like a git diff. You won't ever touch these. Let them always get auto-generated, and check this into source control. And now the next time someone runs npm install on your repo, patch package will run after npm install finishes, and it'll apply all the patches in that patches folder. I caution you, use this tool sparingly. It's very, very powerful, but you shouldn't be jumping to go and make changes in node modules all the time. However, there are legitimate cases where you need to make use of this. Like if the most common thing I've run into is like I need to export a type from like a JSS library. This is a really good way to do that. But even like more relevant to this presentation, say for whatever reason you can't upgrade to JSS 21.6.4. You could actually use this tool to backport that fix that they made to the component level data fetching functions and backport that change into an older version of JSS. So that's a perfectly valid use case and a good use of this tool. So to recap, use patch package to make changes to node modules. The patches get created in the patches folder of your repo. Make sure that anytime you make a patch that you're submitting issues to the package maintainers, and use this sparingly. Documentation can be found at this URL here. And it's a very well documented tool. And I think we've got a bit of time for questions. If you don't have time to ask a question here, feel free to reach out to me on Slack at Sitecore, or you can find me on Mastodon or LinkedIn at those places. So thanks. Go and look in chat.
Great. Thank you, Corey. I don't see any questions in the chat, but guys, all the audience that is around, please feel free. Moloch just dropped one. Which is better method? I want to update a code in Next.js, Next.config.js for getting public URL. Patch config or patch package?
Config plugin for sure. Yeah, you wouldn't use patch package for that. Patch package is just when you want to make a change to the node modules folder for some module. Yeah, you would use a config plugin for that.
Oh, thanks. Yes. Refer back to Dylan in the last presentation. I said I could not imagine a application to use a web API for the component builder. He correctly appointed how non-imaginative I was on that, saying that like if you want to just get an external application creating components dynamically for us, like for instance a Gen AI robot creating components based in any kind of business logic that we can add, you will need a web API for that, of course. Corey, I do have a question for my own. What's your preferred or recommended way for a developer who is working with headless? Things are changing so fast. What is your recommended way to get up to speed or updated as well? Because things are changing this few months.
I mean, yeah, things are changing quickly, but I mean, let's be honest, Sitecore is a bit behind the curve on things. Like, there are a lot of new Next.js capabilities. Like, you can't look up anything about Next.js without hearing about App Router, for example, right? But Sitecore can't make use of App Router yet. There's no official support. Um, so I think like rather than having to worry about staying on the bleeding edge because like where their SDKs are generally a bit behind, I think it's just important to focus on the fundamentals. So if you're coming from a .NET background, the first thing is like don't even worry about Sitecore, don't worry about JSS, don't worry about Next.js, just go learn React and learn how React works because Next.js is a framework built around React. Learn React really well, and from that point, start learning Next.js and learn what that brings to the table, like those server-side rendering methods that I talked about. Those aren't a part of React; those come with the Next.js framework, and kind of learn about those things, and then just kind of layer on right from that point. Like, okay, well, how do I build a site with Sitecore JSS or Sitecore Headless? What does that mean? And then start kind of yeah, just layer on that knowledge. Don't try to dive in and take it all in at once. And you don't certainly don't have to worry about being bleeding edge right now.